Hello, space explorers! Have you ever dreamt of traveling to the moon or Mars? SpaceX is working to make that dream a reality. Their goal: smart, efficient, and sustainable space travel. Think of it like an airplane. Land, refuel, and fly again. SpaceX wants to do the same with rockets. The key is Starship, the biggest, most powerful rocket ever, made of two parts: the Starship spacecraft and the Super Heavy booster. Both are designed to be fully reusable, flying back to Earth after launch, landing safely, and quickly prepping for another mission. This dramatically lowers costs and opens up new possibilities for space exploration. SpaceX has already reused Falcon 9 rockets hundreds of times and is now applying those lessons to the much larger Starship. Each test flight pushes engineering boundaries, with failures leading to rapid improvements. This relentless innovation brings us closer to a future where humans live on other worlds. The latest leap: Starship V3, stronger, more reliable, and faster to relaunch. Let's explore how these upgrades are building the future of space travel, one launch at a time. What makes Starship V3 special? Let's start with the Super Heavy booster's new grid fins. These four giant, waffle iron-like wings at the top steer the booster as it falls back to Earth. On V3, the grid fins are 50% larger and made from a single piece of cast steel, stronger and more durable than before. Larger fins mean better control, guiding the 70-meter-tall rocket to a precise landing. Think of them like the rudder on a boat. The bigger the surface, the more control you have. This upgrade is all about precision and reliability, ensuring safe, accurate landings every time. SpaceX's design philosophy: learn from real flights, iterate quickly, and improve with every launch. After analyzing earlier flights, engineers saw a chance to boost landing accuracy by redesigning the fins. The result: a more robust, easier-to-manufacture fin that makes landings smoother and more dependable. It's a key step toward rapid, reliable rocket reusability. Now let's talk about landing. SpaceX's most futuristic move. Instead of landing legs, the Super Heavy booster is caught mid-air by Mechazilla, a giant pair of arms on the launch tower. The new, larger V3 grid fins are where Mechazilla grabs the rocket. These fins are built with integrated catch points, making them part of the landing hardware. Bigger, stronger fins mean a larger, safer target for the catching arms, crucial when grabbing a skyscraper-sized rocket. This integration of rocket and ground systems is all about efficiency and rapid turnaround. Perfecting this catch is the key to frequent, affordable space launches. When will we see these upgrades in action? Very soon. The next mission, Flight 6, features Ship 37 and Booster 16, incorporating some V3 features. At Starbase in Texas, both vehicles recently passed crucial ground tests, including cryogenic proofing with super-cold liquid nitrogen. During testing, a leak was found in Booster 16's fueling system, quickly fixed by SpaceX's rapid response team. Within days, the booster was back on the stand and passed the test. This speed and problem-solving are hallmarks of SpaceX's approach. With the issue resolved, Flight 6 is set to build on the last mission's success, possibly even attempting the first Mechazilla catch. Every test and fix brings us closer to fully reusable rockets. After tank tests, it's time to check the engines. 33 powerful Raptors on the Super Heavy booster. Instead of a full static fire, SpaceX now uses a spin prime test, flowing super cold propellants through the engine's turbopumps without ignition. This confirms everything works with less stress on the rocket and pad. Booster 16 passed its spin prime test, proving it's ready for launch. No static fire needed. Skipping this step saves time, propellant, and wear, streamlining the pre-launch process. This efficiency is vital for rapid, frequent launches. As SpaceX gathers more data, confidence in the system grows, and testing becomes faster and more refined. The Starship program is maturing, ready for routine operations. While Booster 16 prepares for flight, Booster 18, the first true V3 Super Heavy, is being assembled at Starbase. It features all the V3 upgrades, new generation Raptor engines, easier maintenance, and a vented hot staging ring for better performance. Hot staging lets Starship's engines ignite before booster separation, boosting payload capacity. With integrated hot staging, new engines, and massive grid fins, Booster 18 is the blueprint for future missions to the Moon and Mars. Its assembly marks a turning point. V3 is now real hardware, not just a concept. SpaceX's rapid production means multiple boosters are built and improved in parallel. This factory approach accelerates development and brings interplanetary travel closer. As Booster 16 readies for launch, Booster 18 promises even more power and reliability. Why do these upgrades matter? They're the foundation for humanity's next giant leap. Starship V3 is built for rapid, complete reusability, essential for building a base on the Moon or a city on Mars. For NASA's Artemis missions, Starship must launch frequently to refuel landers in orbit, like topping up your car before a long trip. V3's rapid turnaround and Mechazilla catch make this possible, paving the way for a permanent lunar presence. The ultimate goal? Mars. Colonizing the red planet will require launching hundreds of starships, impossible with expendable rockets. Starship V3 is the first rocket designed for airline-like operations with quick relaunch and reliability. Each improvement, from cast steel fins to hot staging, brings us closer to routine space travel. SpaceX's relentless innovation is turning science fiction into fact. As these rockets soar, we're witnessing the dawn of a new era. The path to the Moon, Mars, and beyond is finally being built, one launch at a time. The future of space is here.